Hello friends. So today's question, a system of two blocks and a light string are kept on two inclined faces which are rough as shown in figure. All the required data are mentioned in the diagram. Pulleys are light and frictionless. So we have to find out three things. If the system releases from rest, then the acceleration of the system is. If the system is initially moving in such a way that the block of 10 kg is coming down the incline with a speed of 2 meter per second, then how much time the system takes to come to the stop. And the third, the variation in the tensions for this A and B part. So let's draw the free body diagram first of all for 10 kg and then for 5 kg, and if we are going to solve it. So let us say for 10 kg, so in the downward direction we are going to have m10g, which can be divided into two components. Let us call this as theta 1. This angle is theta 1. So this will be m10g cos of theta 1, and this will be m10g sine of theta 1, and there will be a normal, that is n10 at tension T, and if it's moving, has a tendency to move in the downward direction, so there will be a friction. Let us call this Fr10. So we can find out value of Fr10. So Fr10 will be equal to mu 10, that is static, and multiply by normal, which is n10, and the value of normal n10 will be m10g cos of theta 1, and we get this as Fr10 is equal to mu 10 multiplied by 10 kg. So this will be 10 g cos of theta 1 is our 37 because of 37 degree. So we can write the equation for motion, and we say that it is moving in this direction with acceleration a. So we get the equation for motion as m10g sine of theta 1 minus t minus of Fr10, which will be equal to m10 multiplied by a. Substitute the values. We can further write this as m10 is our 10, so this is 10g. We have this is sine of theta 1 is 37 minus t, and this is Fr10, which is our mu 10 multiplied by 10g cos of 37, which is equal to 10a. Let us call this equation number 1. Similarly, we can write for 5 kg. For 5 kg, let us draw the free body diagram. So in the downward direction, we are going to have m5g, and let this be theta 2. So this will be our m5g cos of theta 2. This will be m5g sine of theta 2 at tension T, and the frictional force it will be moving up, so frictional force will be acting in the downward direction. Let us call that as Fr5, and in normal let us call that as N5. So we can write the equation for 5 kg block as well. It is moving in upward direction with the acceleration A, so this will be T minus Fr5 minus M5G sine of theta 2 is equal to M5 multiplied by A, and we can find out value of the friction. Fr5 will be equal to mu5 into N5, so we get Fr5 is equal to N5 will be M5G cos of theta 2, so we have mu5 M5G cos of theta 2, and here theta 2 is our 53 degree. We substitute these values and we get the equation as T minus 5G sine of 53 minus mu 5 of G, and that is cos of 53 is equal to 5A, and let us call this equation number 2. So adding equation 1 and 2, adding equation 1 and 2, we get this as 10G sine of 37 and minus 5G sine of 53, and then we get minus mu 10G cos of 37 and minus mu 5 and mu 5G cos of 53 is equal to 15A. So next, in the first part, we are going to find out what will be the net acceleration of the system. So for that, we are going to find out net force, find out the total friction, and make a comparison between them. Okay. We can say net force acting on the system. Net force acting on the system, okay, and let us call this F net. This will be equal to G sine of 37 minus 5G sine of 53. So this will be giving us equal to F net will be equal to 2G, or we can say 20 Newton. Similarly, we are going to find out total frictional force. Total frictional force, let us call this F total, which will be equal to mu 10G cos of 37 plus mu 5G cos of 53. So we get this as F total as Fr total rather will be equal to 2.7 G, or we can say simply 27 Newton. So if you make the comparison between the net force and the frictional force, it can be said that the frictional force is greater than the net force. Okay. Thus, Fr total is greater than F net. Therefore, the blocks do not move. Okay. You can say blocks do not move, or from here we can say the acceleration which is given as A will be 0. Okay. So by making a comparison between the frictional force, we are able to find out that their acceleration will be equal to 0. Next, we are supposed to find out that what will happen if it is moving. Block 10 kg is coming down with the inclined speed down the inclined plane with a speed of 2 meters per second. Okay. So in this case, it is said that it is already in the motion, and we calculated the net force. Okay. So we have part B, which states that as the system is in motion, with initial velocity, that is u, and it is given as 2 meters per second. In this case, now the friction will be the kinetic in nature. Okay, so therefore friction will be kinetic in nature. Therefore, it is given that the mu kinetic for 10 kg is given as 0.25. Okay, we can say that mu kinetic for 10 kg is given as 0.25. So we can find out the frictional force kinetic. You can say Frk for 10 kg is equal to mu k into normal n10, and this value is our coming as 20 Newton. Similarly, we can find out for kinetic for 5 kg, which is given as 0.075. So we can find out the frictional kinetic for 5 kg will be mu k for 10 kg. This is for 5 multiplied by n5, and this will be coming equal to as 9/4 newtons. Now we find out the acceleration A. Okay, and we already know that net force we already calculated, that is F net is about 20 Newton, and we know the frictional forces, the kinetic nature, so we can say that the acceleration A, therefore acceleration A will be equal to F net minus Frk for 10 plus Frk for 5, and divided by a mass of 10 and mass of 5 kg. So if we substitute the value, we get this as A is equal to 20 minus FR10 is also 20 plus 9 by 4 divided by 10 plus 5. So we get this acceleration as 0.15. So now we use the equation for the kinematics. Okay. Using equation of kinematics, V is equal to U plus AT. Now in this case, it is said that it is asked that how much time will it come to stop. Okay, so it means this A is our retardation. Okay, so we can put the equation final velocity is 0. V is equal to U is given as 2. Retardation, so this comes minus 0.15 T. So from here we can say that T is equal to 2 upon 0.5, and we get T is equal to approximately 13.33 seconds. Okay, so we can say from here A is our retardation. And the next we are going to find out variation in tension. So basically means we have two accelerations. The acceleration is 0 and we have acceleration equal to, we found out just that the acceleration is equal to 0.15. So based on this we are going to find out what will be our value of the tension. So let us find out part C, that is variation in tension. Variation in tension. So let us first of all find for A is equal to 0. We already know the equation. We simply substitute value of A as 0 there. Okay. So we take for equation 2. Okay. Using equation 2, we can write T minus 5g sine of 53 minus U5 5g cos of 53 is equal to 5a, and which is equal to 0, and let us call that acceleration as T naught. Okay. So it means for A is equal to 0, let T is equal to T naught. We simply put it here, we get T naught will be equal to, this is 5 multiplied by 10 multiplied by sine of 53 plus we have 0.1 into 5 into 10, and this is cos of 53. So T naught will be coming as equal to 50, this is 0.8, 50 into 0.8 plus this will be 5 into 0.6, 0.6. So we get T naught as 43 Newton. So this is the tension when the acceleration is 0. This is tension when acceleration equals 0. In the second part, for acceleration is equal to 0.1. So under this condition we are once again to use same equation. Okay. And but just remember that acceleration is a retardation. Okay. Retardation. Therefore this will be equal to A is equal to minus 0.15. Once again using the equation, you can directly say that for A is equal to minus 0.15, let T is equal to T.15. So if we put the value, we get T 0.15 is equal to, now the friction will be kinetic, it is moving. So we get this as minus 5A plus 5G sine of 53 plus mu kinetic of 5G, and this will be cos of 53 is, sorry, this will be plus, we put the value of A as minus, so this is minus into 0.15 plus 5 into 10, and this is 0.8. Mu kinetic is 0.075 multiplied by 5 into 10, and this is 0.6. So we can see that tension 0.15 is equal to minus 0.75. This will be coming as 40, and this will be our 2.25. So finally, you can say the tension when the acceleration is 0.5 will be coming as 41.5 newtons. Okay, so this is the tension at, this is tension when acceleration is 0.15. So this completes the question. Thank you.